This video, let's talk about the durability principle of our application, because it's also very important that the enterprise application survive after and remain functional after any kind of errors or exceptions. That's actually what durability means. More formal definition, you can read it into the definition section. So right now, let's try to imagine any kind of example. Let's go back to our example where we have a few customers for, let it be customer 0, let it be customer 1, and let it be customer 2. And all of them sending requests to our API gateway, hoping to get some data from our big cloud application. Right now, let's just take a look and imagine that all of our services and their instances simply working inside one data center. Well, that's for simplicity. So here, databases, let it be 3 databases, and well, any kind of services. Again, for simplicity, I just simply write here service 0 as one service, but yeah, providing high availability. You can imagine that there are a bunch of services. Actually, I don't care how many, because I'm relying on high availability of that service. So here's API, which also includes load balancer at the traffic termination point. What's happening? This scenario. Imagine that we have a chain of services, a chain of operations. Here it would be service 1 and service 2. And all of them are they're not parallel. They running some kind of operations on the incoming requests. Just to go to database, any kind of database in this case, and after retrieving some data, do some modifications and return it back to the request initiator. Now, imagine that service 1 got some error and it stops operating. I don't know what happened there. It could be everything. Well, maybe the customer just saying wrong data. Maybe there could be some error in logic, in application logic. Doesn't matter. But what we can see is that, let's say, service 0 initiated request to service 1. Let's call it request 1. Service 1 initiated, well, it just managed it somehow, just do any kind of modifications. For example, just go to its own database, grab some data, I don't know, just do something and send the next request to service 2. Service 2 have a direct access to main database, it retrieved data, go back, and then somehow service 1 didn't get what it expected and didn't return anything to service 0. Instead, as a response, let it be response 1 to request 1. As a response, service 1 returned error. So the response in this case, error. Is that a bad situation? Obviously, yes. It doesn't look good. So, well, it means that somehow service 0 wouldn't return, let's say, to customer 0 the expecting data, and customer 0 should deal somehow with that errors. Moreover, since the service 1 start malfunctioning, it could just mean that this service maybe just need to get restarted, or maybe the data corrupted in database and it requires some maintenance. So durability here is kind of silver bullet, but not for all cases, of course. For some very common, some very specific. But using durability in a correct way, we can survive in this situation in such a way that customer 0 even doesn't know that somewhere here there were an error, or one error or many errors, doesn't matter. So how is that possible? Again, let's go back to the situation where the service 1 returns an error. Can we just push somewhere into our code base of service 0 an expectation of that error? For example, in terms of Java, let's try to imagine we push there any kind of try catch block. Where we actually expecting that exception. And here we have some logic how to deal with that exception. Is that possible? Yes, of course, it is possible. So here in this block, we can simply ask, okay, we know that, imagine the situation, we know that, for example, these databases are NoSQL databases. For example, it could be CouchDB, MongoDB, anything. It could be even Cassandra. And different nodes, they are based on the CAP theorem. We will talk about it a little bit later. Provide us the persistent tolerance. They provide us consistency of the data, but they do not provide us immediate availability of the data, which means that somewhere here data is modified and it's already exist in this node, but here data simply is not updated yet. It will be updated eventually, but at the time of request from customer 0, these data simply doesn't exist in this node of this database. And that's why service 1 just throws an error. How to handle that situation inside this try catch? What we can do is a very, very simple solution. Well, I think you just think of that solution. You can push here any kind of timeout. For example, I don't know, 1 second, and then retrieve the operation. In this case, when data will be propagated inside the other nodes of the NoSQL database, eventually, even though you have an exception here in this service 1, eventually the service 1 will wait for the data, for the proper data, and return it back to service 0, and service 0 respond to customer 1, and customer 1 simply doesn't even guess that something went wrong during this chain of requests. And that's what durability means.